A double-throw double-pole, abbreviated DPDT, disconnect switch meets the current requirements of the National Electrical Code, or NEC, for generators. NFPA 70 Article 702.5 requires a double-pole disconnect switch for generators that are not permanently connected to the building's electrical system. NFPA 70 Annex D specifies that a DPDT switch can be used as a double-pole disconnect switch for generators. One of the main advantages of using a DPDT disconnect switch is safety. It isolates the generator from both the utility power and the building's electrical system, ensuring safety during maintenance and repairs. Using a DPDT disconnect switch also ensures compliance. It meets the NEC requirements for generator installations. DPDT switches are readily available and relatively easy to install. When selecting and installing a DPDT disconnect switch, it is important to note that the DPDT disconnect switch should have an ampere rating equal to or greater than the generator's output. The DPDT disconnect switch should be located in an accessible location, preferably near the generator and the utility disconnect switch. Proper grounding and bonding must be provided according to the NEC. Instead of a DPDT disconnect switch, an automatic transfer switch, or ATS, can be used to automatically transfer power between the utility and the generator during a power outage. An interlock can be installed to prevent the generator from operating while the utility power is available, ensuring safety and compliance. To summarize, a double-pole double-throw disconnect switch is a suitable solution for generator installations, meeting the requirements outlined in the National Electrical Code. It provides safety by isolating the generator from both the utility power and the building's electrical system. This isolation is crucial for maintenance and repairs, protecting personnel from electrical hazards. Its compliance with NEC standards makes it a reliable choice for ensuring that the installation adheres to established safety and regulatory guidelines. Moreover, the ease of installation and the ready availability of DPDT switches make them a practical option for many homeowners and electricians. When installing a DPDT switch, several key considerations should be taken into account. Firstly, the ampere rating of the switch must be equal to or greater than the generator's output. This ensures that the switch can handle the full load of the generator without overheating or failing. Secondly, the location of the switch should be easily accessible and preferably situated near both the generator and the utility disconnect switch. This facilitates quick and convenient switching between the generator and utility power sources. Thirdly, proper grounding and bonding are essential for safety and compliance with the NEC. These measures help to prevent electrical shocks and ensure that the electrical system functions correctly. Although a DPDT disconnect switch is a viable option, an automatic transfer switch, or ATS, offers a more automated solution. An ATS automatically transfers power between the utility and the generator during a power outage, eliminating the need for manual intervention. This can be particularly useful in situations where a continuous power supply is critical. An interlock system can also be installed to prevent the generator from operating while the utility power is available. This safety feature helps to avoid backfeeding power into the utility grid, which can be dangerous and is often prohibited by local regulations. In summary, using a double-pole double-throw disconnect switch for generator installations is a code-compliant and safe option, provided that the appropriate ampere rating is selected, the switch is installed in an accessible location, and proper grounding and bonding are implemented. While an automatic transfer switch offers a more automated solution, a DPDT switch remains a practical and cost-effective choice for many applications. Understanding the requirements and advantages of each option allows you to make an informed decision that best suits specific needs and circumstances. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including those involving generators. Adhering to these guidelines ensures safety and compliance, protecting both property and people from electrical hazards. The NEC is updated regularly to reflect advancements in technology and best practices in the electrical industry. Therefore, it is important to consult the latest edition of the NEC when planning and executing electrical installations. The double-pole double-throw disconnect switch serves as a critical component in a generator system, allowing for the safe and reliable transfer of power between the utility grid and the generator. Its double-pole design ensures that both hot wires are disconnected simultaneously, preventing any potential for current leakage or backfeeding. The double-throw mechanism allows the switch to be easily toggled between the utility and generator power sources, providing a simple and effective means of managing power during outages. Proper installation and maintenance of the DP-DT switch are essential for ensuring its continued reliability and safety. Regular inspections should be conducted to check for any signs of wear or damage, such as loose connections, corroded contacts, or cracked insulation. Any issues should be addressed promptly to prevent potential problems. In addition to the DP-DT switch, other components of the generator system, such as wiring, circuit breakers, and grounding electrodes, should also be inspected and maintained regularly. A well-maintained generator system will provide reliable power during outages and ensure the safety of the electrical system. When selecting a DP-DT switch, it is important to consider the specific requirements of the generator system, including the voltage, current, and power ratings. The switch should be rated to handle the full load of the generator without overheating or failing. It is also important to choose a switch that is compatible with the wiring and other components of the electrical system. Consulting with a qualified electrician can help ensure that the correct DP-DT switch is selected and installed properly. The automatic transfer switch, or ATS, is a more sophisticated alternative to the DP-DT switch. An ATS automatically detects power outages and switches the power source from the utility grid to the generator. When utility power is restored, the ATS automatically switches the power source back to the utility grid. This eliminates the need for manual intervention and ensures a seamless transition between power sources. ATS systems often include additional features, such as remote monitoring and control, which can be useful for managing the generator system from a distance. The choice between a DP-DT switch and an ATS depends on the specific needs and budget of the application. A DP-DT switch is a more cost-effective solution for basic generator systems, while an ATS is a better choice for applications that require a high level of automation and reliability. Regardless of which option is chosen, it is important to ensure that the generator system is installed and maintained properly to ensure its safety and reliability. The installation of a generator and its associated transfer switch, whether it be a manual DP-DT or an automatic ATS, must comply with all applicable local and national electrical codes. These codes are designed to protect people and property from electrical hazards and ensure that the electrical system functions safely and reliably. It is important to consult with a qualified electrician to ensure that the installation meets all code requirements. In addition to the electrical code requirements, there may also be local permitting requirements for generator installations. These permits are typically required to ensure that the installation meets local zoning and building codes. It is important to check with the local authorities to determine whether any permits are required before starting the installation. The generator itself should be chosen based on the power requirements of the home or business. It is important to calculate the total power consumption of all the appliances and devices that will be powered by the generator during an outage. The generator should be sized to handle this load, with some extra capacity for future expansion. Overloading a generator can damage it and create a fire hazard. Proper ventilation is also essential for generator installations. Generators produce exhaust fumes that can be harmful or fatal if inhaled. The generator should be located in a well-ventilated area, away from windows, doors, and other openings that could allow exhaust fumes to enter the building. A carbon monoxide detector should be installed in the building to alert occupants to the presence of dangerous levels of carbon monoxide. Regular maintenance is essential for ensuring the continued reliability of the generator. The generator should be inspected regularly for any signs of wear or damage. The oil and filter should be changed according to the manufacturer's recommendations. The generator should also be run periodically to ensure that it is in good working order. Following these guidelines will help to ensure that the generator is installed and operated safely and reliably. Generator safety is paramount when using these devices as backup power sources. Carbon monoxide poisoning is a serious risk associated with generator use. Never operate a generator indoors or in enclosed spaces, including garages, basements, and sheds. Always place the generator outdoors in a well-ventilated area, away from windows, doors, and vents that could allow carbon monoxide to enter the building. Install carbon monoxide detectors with battery backup on every level of the home and check them regularly to ensure they are functioning properly. Fueling a generator can also be hazardous. Always turn off the generator and let it cool down completely before refueling. Use a funnel to avoid spills and wipe up any spilled fuel immediately. Store fuel in approved containers away from the generator and other ignition sources. Never smoke or use open flames near the generator or fuel storage area. Electrical hazards are also a concern when using generators. Make sure the generator is properly grounded according to the manufacturer's instructions. Use heavy-duty extension cords that are rated for outdoor use and can handle the generator's electrical load. Avoid overloading the generator with too many appliances or devices. If using a transfer switch, make sure it is properly installed and operated according to the manufacturer's instructions. Never attempt to connect the generator directly to the home's electrical wiring without a transfer switch, as this can create a dangerous backfeed situation that could injure or kill utility workers. Children and pets should be kept away from the generator at all times. The generator's hot surfaces and moving parts can cause burns and injuries. Store the generator in a secure location when not in use to prevent unauthorized access. By following these safety guidelines, you can minimize the risks associated with generator use and ensure the safety of your family and home. Double-pole, double-throw disconnect switches are rated by their amperage and voltage capacity. Ensure that the switch you select can handle the maximum current and voltage that the generator can produce. For example, if a generator is rated for 30 amps at 240 volts, the DP-DT switch must be rated for at least 30 amps at 240 volts or higher. It is always better to choose a switch with a slightly higher rating to provide a safety margin and prevent overheating. The DP-DT switch should be installed in a readily accessible location where it can be easily operated during a power outage. The switch should be mounted on a sturdy surface and protected from the elements. The wiring connections to the switch must be secure and properly insulated. Use appropriate wire connectors and ensure that all screws and terminals are tightened properly. Label the switch clearly to indicate which position connects to the utility power and which position connects to the generator power. This will prevent confusion during an emergency. When using the DP-DT switch, always follow the proper sequence of operations. Firstly, turn off all major appliances and devices in the home to reduce the load on the generator. Secondly, start the generator and let it warm up for a few minutes. Thirdly, switch the DP-DT switch to the generator position to transfer power to the home. When utility power is restored, reverse the sequence of operations. Firstly, switch the DP-DT switch to the utility position. Secondly, let the generator cool down for a few minutes. Thirdly, turn off the generator. Finally, turn on the major appliances and devices in the home gradually. It is important to understand the limitations of the generator and the DP-DT switch. Generators are not designed to provide continuous power for extended periods. Overusing the generator can shorten its lifespan and increase the risk of breakdowns. The DP-DT switch is a manual device that requires human intervention to transfer power. It is not suitable for applications where automatic power transfer is required. In such cases, an automatic transfer switch is a better option. An automatic transfer switch, or ATS, is an electrical device that automatically switches a load between two power sources. In the context of a generator system, the ATS switches the load between the utility power and the generator power. When utility power is available, the ATS connects the load to the utility power. When utility power fails, the ATS automatically disconnects the load from the utility power and connects it to the generator power. When utility power is restored, the ATS automatically switches the load back to the utility power. ATES systems are available in a variety of configurations and sizes to suit different applications. Some ATES systems are designed for residential use, while others are designed for commercial and industrial use. The selection of an ATES depends on the size of the load, the type of power sources, and the desired level of automation. One of the key advantages of an ATES is that it provides seamless power transfer. There is no interruption of power to the load when the ATES switches between power sources. This is particularly important for critical loads, such as medical equipment, computers, and security systems. Another advantage of an ATES is that it eliminates the need for manual intervention. The ATES automatically switches between power sources without any human action. This is convenient and reduces the risk of human error. ATES systems also provide protection against various power problems such as voltage fluctuations, frequency variations, and overcurrents. The ATES can disconnect the load from the power source if it detects any of these problems, protecting the load from damage. The installation of an ATES requires the services of a qualified electrician. The electrician will ensure that the ATES is properly connected to the electrical system and that it meets all applicable codes and regulations. Regular maintenance is also important for ATES systems. The ATES should be inspected regularly for any signs of wear or damage. The batteries should be tested and replaced as needed. The ATES should also be tested periodically to ensure that it is functioning properly. The cost of an ATES can vary depending on the size, features, and brand. However, the benefits of an ATES in terms of reliability, convenience, and protection can often outweigh the cost. When choosing an ATES, it is important to consider the specific needs of the application. The ATES should be sized to handle the load, compatible with the power sources, and provide the desired level of automation and protection. Consulting with a qualified electrician can help you select the right ATES for your needs. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety and reliability of electrical installations. The NEC is not a law, but it is adopted by many state and local jurisdictions. In these jurisdictions, compliance with the NEC is mandatory. Even in jurisdictions where the NEC is not mandatory, it is considered a best practice to follow its guidelines. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC is often complex and difficult to understand. It is important to consult with a qualified electrician to ensure that electrical installations comply with the NEC. The NEC provides detailed requirements for generator installations. These requirements cover topics such as the location of the generator, the wiring methods, the overcurrent protection, and the grounding. The NEC also requires the use of a transfer switch to isolate the generator from the utility power. The transfer switch must be rated for the maximum current and voltage that the generator can produce. The NEC also requires that the generator be properly grounded to prevent electrical shock hazards. The grounding system must be installed in accordance with the NEC requirements. Compliance with the NEC is essential for ensuring the safety and reliability of generator installations. Failure to comply with the NEC can result in fines, penalties, and even legal action. It is important to consult with a qualified electrician to ensure that generator installations comply with the NEC. Electrical safety is of paramount importance when dealing with electricity. Electricity can be dangerous and can cause serious injuries or even death. It is important to take precautions to protect yourself and others from electrical hazards. Never work on electrical equipment unless you are qualified and trained to do so. Always turn off the power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never touch electrical equipment with wet hands. Keep electrical equipment away from water and other liquids. Inspect electrical equipment regularly for any signs of wear or damage. Replace damaged electrical equipment immediately. Never overload electrical circuits. Use extension cords sparingly and make sure they are rated for the load. Be aware of overhead power lines and keep a safe distance from them. Call a qualified electrician if you have any questions or concerns about electrical safety. Carbon monoxide is a colorless, odorless, and tasteless gas that is produced by the incomplete combustion of fuels such as gasoline, propane, natural gas, and wood. Carbon monoxide is toxic and can cause serious health problems or even death. Generators produce carbon monoxide, so it is important to operate them safely. Never operate a generator indoors or in enclosed spaces. Always operate the generator outdoors in a well-ventilated area, away from windows, doors, and vents. Install carbon monoxide detectors with battery backup in your home to alert you to the presence of carbon monoxide. Test the carbon monoxide detectors regularly to make sure they are working properly. If you experience symptoms of carbon monoxide poisoning, such as headache, dizziness, nausea, or shortness of breath, get fresh air immediately and seek medical attention. Electrical grounding is a critical safety measure that helps to protect people from electrical shock hazards. Grounding provides a low resistance path for electrical current to flow back to the source in the event of a fault. This helps to trip the circuit breaker or fuse and energize the circuit, preventing electrical shock. All electrical equipment and wiring should be properly grounded in accordance with the NEC requirements. The grounding system should be inspected regularly to ensure that it is in good working order. If you have any questions or concerns about electrical grounding, contact a qualified electrician. Proper bonding ensures electrical continuity and a safe path for fault current to flow back to the source. Bond all metallic parts of the electrical system together, including metal conduits, enclosures, and equipment grounding conductors. Use appropriate bonding connectors and techniques to ensure a secure and reliable connection. Inspect bonding connections regularly for corrosion or looseness and repair or replace as needed. By following these safety guidelines, you can minimize the risks associated with electricity and ensure the safety of your family and home.